Okay, with part B, we're going to repeat the same process. The goal is to find the equation of a normal line to the graph at the specified point, which requires that we need a point and a slope, dy dx. That slope dy dx evaluated at the point will be the tangent slope, and if we want the normal slope, we'll need to take the opposite reciprocal. So for part B, we would write the point is 0, 1. The slope will be the opposite reciprocal of dy dx evaluated at the point. So in order to compute that, I need to know what dy dx is. So to find dy dx, I'm going to do the process that was taught in section 3.6 skill 1, which involves applying the derivative operator to both sides of the equation. Running it through, I'll have a 4 plus, I have to do the product rule, 2x times hit the power inside unchanged times the derivative of the inside. So there's the first times the derivative of my second plus the second times the derivative of my first. Move through the addition, hit the power again, and multiply by the derivative of the y. And then on the right side, I have the derivative of the constant, which is 0. So if I want to isolate dx, I need to first identify the terms that involve dy dx and the terms that do not involve dy dx. I will move the 2y squared and the 4 to the other side, and I'll factor the dy dx and write the leftovers. So I have a 4xy left over in this term and a 3y squared left over in the other. So if I isolate dy dx now, I will end up getting a negative 2y squared minus 4 over a 4xy plus a 3y squared on the bottom. If I evaluate this now at 0, 1, everywhere that there's an x, I'll plug in a 0. Everywhere that there's a y, I'll plug in a 1. So I'll have a negative 2 minus a 4 over a 0 plus a 3. So that gives me a negative 6 over 3, which is a negative 2. Therefore, my normal slope will be the opposite reciprocal of that, which is 1/2. Put those two together, I'll get y equals 1/2 times x minus 0 plus 1. Part C excuse me, works the exact same way. So let me flip this over here. I need the point, which is 2, 1. I need the slope, which will be the opposite reciprocal of dy dx evaluated at the point. So to find that slope, I need to take the derivative with respect to x on both sides. So I'm applying the operator ddx to both sides of that equation. When I do that, I end up with a dy dx on the left. Here I'll have the product rule, so the first one times the derivative of the second, plus the second times the derivative of the first. Move through the minus, hit the x cubed, that'll be a 3x squared dx dx, which is a 1. Hit the constant, which is a 0. I have two terms now that involve dy dx, and they're on different sides of the equation. So I need to get them together first so that I can then factor out that dy dx. And I'll leave the things that don't have dy dx's in them on the other side. So here, if I factor out my dy dx, I will be left with a 1 minus a 5x, and on the other side, 5y minus a 3x squared. So if I isolate dy dx now, I have a 5y minus a 3x squared over a 1 minus a 5x. If I evaluate at the point 2, 1, that means everywhere I've got an x, I'll put a 2. Everywhere I've got a y, I'll put a 1. So I get a 5 minus a 12 over a 1 minus a 10. That gives me a negative 7 over a negative 9, or a 7/9. That is my tangent slope. So my normal slope will be the opposite reciprocal of that, which is negative 9/7, I can now put the point and the slope together and write the equation of the line. Y equals the slope times x minus the x coordinate plus the y coordinate.